All right, now we're going to talk about scientific notation. Scientific notation is just another way of writing numbers that are really, really big or really, really small. For instance, if we write out a number that you should all be familiar with, 6.02 times 10 to the 23rd particles. What that really means or 23 places that we've moved. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay? Much easier to write shorthand. Okay? Now think of it this way. Think of it this way. If I have 500 monkeys, that's the same as saying that I have 5 groups of 100 each, right? 100, this is kind of like the new math, the Common Core math. This is the same as 500. Okay? So you can say 5 times 100 equals 500. Now, we like to use powers of 10. So we could say 50 times 10. That would also equal 500, right? If we have 5 times 100, 100 when we write it as a power of 10 is 10 times 10, right? So we could say 5 times 10 times 10. If we shorten that up, 5, we have 2 sets of 10s, 5 times 10 to the second. And we get 500. Okay? So all we're doing is removing that huge number. If I have the number 7,021, 210. Okay? What that is, we've got 7 times 100, and then we have 210. 7 times 100, this 100 is 10 to the second, and it would be 7.210. 7.21. And we can drop this because we just learned about significant figures. There's no decimal present, so we drop that. So it'd be 7 times 10 to the 21st is times 10 to the second. 7.21 times 10 to the second. Okay? So let's try a couple. If I tell you we have 5.38 times 10 to the 8th, what's that going to be? Well, you just do 5.38 times 10 to the 8th, which would be 10 times 10 times 10 times 10 times 10 times 10. Lots of tens. 4, 5, 6, 7, 8. Okay, if we do that out, we get 538, right? 538 billion would be the same as 5.38 times 10 to the 8th. If you basically, and honest to God, you just saw me do all those swoopies up there. This is still how I do it. If I see 5.38 times 10 to the 8th, I'm going to draw in 8 placeholders. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to fill these with the zeros. Now remember we talked about whether they're significant or not. These are just holding a place. They're not significant. Okay? All right, let's think about small numbers now. What if you have I can't even tell you how we would name that. It would be tenths, hundredths, thousandths, 10,000ths, 100,000ths. So 7 100,000ths. So the number's too small. But we can make it easier to work with. Okay, this is less than 1. Okay, so if this is 10 to the second is equal to 100, 10 to the negative second is going to be equal to 1/100th. right? Yeah. 1/100th. No, just one. Yeah, that's 1,000th. So I didn't write it right. 1/100th. Okay? So this number is the same as saying, if we move our decimal over 1, 2, 3, 4, 5. We moved it 5 to the right. 7.82. Since we moved it 5 to the right, we're going to write minus 5. If we move them to the left, it's positive. So 7.82 times 10 to the negative 5th. Okay? If I give you this number, 3.75 times 10 to the negative 14th, and you wanted to write that out, what are you going to do? Well, remember what I said. I still do the swoopies, even to this day. This time it's in scientific notation, so I'm going to swoop out 14 to the left. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 11, 12, 13, and there's the 14th spot. So a 0.0 in front of all those is the same as 3.75 times 10 to the negative 14. All right, here's some notes. It's a form of writing very large or very small numbers, and we use power of 10. The decimal point is put behind the first non-zero number. The power of 10 is the number of times it moved to get there. In other words, it's going to be the placeholder, or like the tens place or the 100s place. A number that begins large is positive, and a number that begins small is negative exponents. Okay? We will have some examples in class, but I wanted to give you this information. Thank you very much.